Hello everyone. Today we're going to talk about energy transformations and conservation. How are different forms of energy related? What does flowing water have to do with electricity? In a hydroelectric power plant, the mechanical energy of moving water is transformed into electrical energy. All forms of energy can be transformed into other forms of energy. Let me say that again. All forms of energy can be transformed into other forms of energy. A change from one form of energy to another is called energy transformation. Some energy changes involve single transformations, while others involve many transformations. Single transformations, sometimes one form of energy needs to be transformed into another to get work done. For example, a toaster transforms electrical energy to thermal energy to toast your bread. Remember, thermal energy is also known as heat energy. A cell phone transforms electrical energy to electromagnetic energy that travels to other phones. Your body transforms the chemical energy in food to mechanical energy you need to move your muscles. Chemical energy in food is also transformed to thermal energy your body uses to maintain its temperature. Multiple transformations. Often a series of energy transformations is needed to do work. For example, the mechanical energy used to strike a match is transformed first to thermal energy. The thermal energy causes the particles in the match to release stored chemical energy, which is transformed to more thermal energy and to the electromagnetic energy you see as light. In a car engine, another series of energy conversions occurs. Electrical energy produces a spark. The thermal energy of the spark releases chemical energy in the fuel. The fuel expands as it is broken down into smaller particles. The expansion of the fuel produces pressure on parts of the car. The increased pressure eventually causes the wheels to turn, transforming chemical energy into mechanical energy. If you look at our application, a series of energy transformations must occur for you to ride your bike. Obviously here, the reactions occur within the sun, transform blank energy into blank. Plants transform blank energy into blank. And then it continues with your body transforming blank energy into blank energy when you ride your bike. So if you come over here to the sun, you're talking about light and heat. And specifically, plants will take that light and transform it into chemical energy in the process of photosynthesis. Now, to be more specific about the sun, I apologize, I skipped. To be more specific about the sun, they're using nuclear energy, specifically nuclear fusion, for the energy production, and it's transferred into or transformed into the light energy and the heat energy. The plants specifically take the light energy and make it into chemical energy. And then the body breaks down the chemical energy that we eat from the plants and turns it into different heat energies and other energies for our body so we can use it to ride a bike. Let's continue. Kinetic and potential energy. The transformation between potential and kinetic energy is one of the most common energy transformations. For example, when you stretch a rubber band, you give it elastic potential energy. If you let it go, the rubber band flies across the room. When the rubber band is moving, it has kinetic energy. The potential energy of the stretched rubber has transformed to kinetic energy of the moving rubber band. Transformations between kinetic and potential energy can also occur in any object that rises or falls. The falling object, a pendulum, or a pole vault are all examples of these transformations. Here's a good example of a pole vaulter right here, going up and over. Falling objects. A transformation between potential and kinetic energy occurs in a ball, see figure 1. As the height of the ball decreases, it loses potential energy At the same time, its kinetic energy increases because its speed increases. Its potential energy is transformed into kinetic energy. So if we look at the ball here, as it is being held by this person in their hand, it is full of potential energy and zero kinetic energy because it is not moving, it's at rest. When they release the ball, the level of potential energy goes down and the kinetic energy level goes up. So whatever the energy level is, let's say it's 16 joules, at this point right here where it's being held in the hand, that 16 joules is all potential energy. And then as that person releases the ball, that potential energy changes to kinetic. So it's still 16 joules, but the level of potential is decreasing and the kinetic is increasing as it goes down. Okay? Let's go down here. Pendulum. The pendulum, like the one in figure 2, swings back and forth. At the highest point on its swing, the pendulum has no movement. As it swings downward, it speeds up. The pendulum is at its greatest speed at the bottom of its swing. As the pendulum swings to the other side, its height increases and its speed decreases. At the top of its swing, it comes to a stop again. This is a picture of that. We'll see that in more detail shortly. So this is the pendulum we were talking about earlier. If I pull this one steel ball back, it has potential energy. When I let go, that potential energy changes to kinetic. So if it's 16 joules of potential energy here, when I let go, the zero kinetic energy will be transferred from potential to kinetic. So when it hits its speed here, that 16 joules is more kinetic. Now, when this hits, the energy transfer is going to go through the balls and come out here, and you'll see the ball go over here. Okay? This is also an example of Newton's third law of motion. For every action, there's an equal and opposite reaction. Same thing if I pulled 2 back, you'd have the same reaction on the other side. Again, changing from potential to kinetic energy when I let go. Once again, for every action, there's an equal and opposite reaction. So if there's 3 pulled back, equal and opposite should be 3. Just as Newton's law said. And here you can see the transfer from one side to the other with the energy. What is the law of conservation of energy? Once you set a pendulum in motion, does it swing forever? No, it does not. Then what happens to its energy? Is the energy destroyed? Again, the answer is no. The law of conservation of energy states that when one form of energy is transformed to another, no energy is lost in the process. According to the law of conservation of energy, energy cannot be created or destroyed. Once again, the law of conservation of energy states energy cannot be created or destroyed. The total amount of energy is the same before and after any transformation. If you add up all of the new forms of energy after a transformation, all of the original energy will be accounted for. So what happens to the energy of the pendulum once it stops moving? As the pendulum swings, it encounters friction at the pivot of the string and from the air through which it moves. Whenever a moving object experiences friction, some of its kinetic energy is transformed into thermal. So, the mechanical energy of the pendulum is not destroyed, it is transformed to thermal energy, which is also heat energy. The fact that friction transforms mechanical energy to thermal energy should not surprise you. After all, you take advantage of such thermal energy when you rub your cold hands together to warm them up. Friction is also the reason why no machine is 100% efficient. You may recall that the work output of any real machine is always less than the work input. This reduced efficiency occurs because some mechanical energy is always transformed into thermal energy due to friction. This concludes our shared reading on energy transformations and conservations. We hope you enjoyed this time. Thank you. Goodbye.